All right, in this problem, I have a circuit, and this switch here, when it's open versus when it's closed, the resistor value doubles. So when the switch is closed, the value of R for the total circuit, the current in resistor R doubles. So the resistance gets cut in half, right? Current I in resistor R doubles when the switch is closed. Okay, so to solve this, we need to look at what it looks like open versus closed, right? So first, let's look at the circuit when the switch is open. So we'll call this switch open. Okay, so when the switch is open, the circuit should look like this. We'll say REQ, here's my battery, here's R, and then it goes up, and when this switch is open, that thing is basically not there, right? So it's just like two things that are in series with each other. So here's one, and here's the other. Like that. All right, and so what is it? This is 10, that's 90, that's 10, that's 90, right? So when the switch is open, it behaves like this. So we could get the equivalent resistance, right, by adding our resistors in series and parallel. So these are series, I add those. These are series, I can add those. And then these two things are in parallel, so I can do that. And I can get an equivalent resistance. It's going to equal R plus whatever this is, right? So I don't know what R is. I'm trying to figure it out. So whatever number I get here, I'm going to call my equivalent resistance R plus something, whatever the value of this is, right? And that'll be for the switch open. Now let's do the same thing for the switch closed. So when the switch is closed, the equivalent resistance is going to look like this. So now when I close the switch, this is all connected, right? That's connected, that's connected. So it's basically two little sets of parallel resistors that are in series with each other. So let me draw it so I can show you. So there's my battery, here's my resistor R, and then it comes up and basically splits like this. So see how these two are parallel with each other? So that's these two. So that's a 10 and a 90. And then this is all connected, so I'm just going to make that a little wire. And then it splits again. There's one and there's the other. All right, so this one's 90. Again, it's these two, 90 and 10. And then it comes back down and goes to there. Right? So here, I'm going to do the same thing, right? So REQ for this one is going to equal R plus whatever I get here, right? Because R is in series with whatever this combination is. And to do this one, I would add these parallel first. And then I would add those parallel, right? And get those two numbers. And now those are in series with each other. So now I can add them in series. And again, R is in series with that whole thing. So my equivalent resistance is R plus another number, right? Okay. So now that we've done this, I have two things. Both of them have an unknown R in it. So how do I figure out R, right? I've got some number here and some number here. So I can take what I know about the current to figure out R. So if the current doubles, that causes the resistance to decrease by 2 times, right? Doubling the current means the resistance decreased by 2 times because same voltage equals current times resistance, right, from Ohm's law. So I can take this and I can use that to relate these two things. So that means that the closed resistance has to equal half of the open resistance because when the current doubles when the switch is closed. So that means when the switch is closed, the resistance is smaller than it was. So it's going to equal the open resistance divided by 2, right? Because it doubles, it's going to decrease by 2 times. So now if I take this number and I plug it in here, right? If I take this number and that's open, so that's going to go here, and I take this thing and I stick it here, I can write an equation to relate these two, right? So it's going to look like this. It's going to say REQ, it's going to say R plus something for the closed one equals 1/2 times whatever the open one was, R plus something. And so now I've got an equation, right? I've got numbers here that are constants I can distribute the half in, and then I just have an unknown R, and you can solve for what R is going to be. But it involved first relating open versus closed and finding the equivalent resistance first. And then you can take the relationship, knowing that the current is going to double, that means the resistance has to get cut in half. And then we can write this little equation and solve.